Bismillah ar-Rahman ar-Rahim. We'll continue doing this 7.6 where we have multiple eigenvalue solutions. If you have multiple eigenvalue, how we can deal with the solutions. This is what we did before. We said if I can get, assume I have lambda multiplicity k and I can get exactly k linear independent eigenvectors, then this will be the form, easy one. like in the case of real distinct, V1 E lambda T, V2 E lambda T, Vk E lambda T. And we did an example. In the case of multiplicity 2, and we can get only one eigenvector. So we'll do this procedure, this algorithm, where I compute A minus lambda I at D plus 1, which is square in this case. Since D is 1, the defect is 1. And I try to find a non-zero vector, U, choose one, so that A minus lambda I all square times U1 is 0, but A minus lambda I times U1 not equal to 0. You find U1, you get U2. This is the form. Then we have this case, multiplicity 3, and defect D equal to D equal to. So we'll find A minus lambda I D plus 1, which is now cubed. Now then I try to choose a vector U1, so that A minus lambda I cubed times U1 equals 0, but the squared one not equal to 0. You find U2, A minus lambda I times U1, then you find U3, A minus lambda I U2, then you have this format for the solutions. And we did an example. Now if you have defect D equal to, so you have two linear independent eigenvectors. So these two linear independent eigenvectors, I will do like the real distinct, V1 E lambda T, V2 E lambda T. And for the third one, I'll do the same procedure like what we did before. So I have A minus lambda I square. In this case, since D is 1. I try to find U1, so that A minus lambda I square equal U1, but A minus lambda I U1 not equal to 0. I find A minus lambda I square times U1 is equal to 0, but A minus lambda I U1 not equal to 0. Then I find U2. Then I find this format, U2T plus U1 E lambda T. And then we did an example. The general case where we have, in general, if we have D, by the way, in our course, I think we are concerned only maximum about 3 by 3. So we have only these cases, but this is the general case. What the thing is, what we are getting, these are not eigenvectors anymore. These are generalized eigenvector. We call them generalized eigenvector. The one we are doing with these algorithms, because they will not satisfy the condition AV equal lambda V, which is the main definition for the eigenvector. So this is the procedure. Yeah. It depends on D. I need to have this is square, but the one before it not equal to 0. Then try to do the rest. And this is the format for the solution. But as I said, in our course, we are concerned only about 2 by 2 or maximum 3 by 3 matrices. So the algorithm which I talked about before, there will be a good this is what we need exactly. Now what I will do, I'll try to do more examples. Yeah, try to do more examples, and then we'll go to all the exams questions. Okay. Now what I will do, I need to find lambdas, the eigenvalues. So I have minus lambda, A minus lambda I, I need A minus lambda I equal to 0. I need to solve this equation. 1, 2, minus 5, minus 3, minus lambda, minus 7. 1, 0, minus lambda. How to do that? I'll do expansion with the third row. So I have 1, cancel the third row and the first column. I have 1, 2, be careful because it has minus plus, so let me do it carefully. Minus 3, minus lambda, and this is 7, minus 7, yeah. Minus lambda Because in the third row, and the third column, minus lambda 1, minus 5, minus 3, minus lambda. Let us see what will happen. I have this one time, so I have minus 7 plus 6 plus 2 lambda. Okay, minus lambda times what? This is lambda square plus 3 lambda plus 5. Is it? Yeah, minus 5, which is plus 5. That will be what? This is minus 1. So minus 1 plus 2 lambda minus lambda cube minus 3 lambda square minus 5 lambda minus 5 lambda. Okay, which I can rewrite it minus lambda cubed minus 3 lambda square minus 3 lambda minus 1, which will minus lambda cube plus 3 lambda square plus 3 lambda plus 1. I don't know if you know this, but this is lambda plus 1 all cubed. So it means my lambdas minus 1, minus 1, minus 1. Repeat it 3 times. So I have multiplicity 3. I have multiplicity 3. Let me see how many eigenvectors I can get. So we solve A minus lambda I V1 equals 0 to find how many eigenvectors. What I will get, 0 minus 1, that will be 1, 1, 2. This is minus 5. Minus 3 minus 1, that will be minus 4. I add 1 to the diagonals. 0, 0. Yeah, it's not 0, it's 1. 1, 0. And the last one will be 0 minus 1, that will be 1. Times K1, K2, K3 equals 0, 0, 0. Yeah. I need to deal with this system. Try to manipulate it the right way. I have K1. Yeah, you know what? I can do it by Gauss elimination. I think Gauss elimination will help. Especially I have 1 here, so that will make the calculation easier. 1, 1, 2, 0. Minus 5, minus 2, minus 7, 0. 1, 0, 1, 0. So multiply by 5 the first row and add it to the second row. I have 0. 5 minus 2, 3. 10 minus 7, 3, 0. So I have now, I'll multiply by minus 1 and add, that will be 0. Minus 1 and add, that will be minus 1. Minus 1 and add, that will be minus 1 also. Now divide by 3, the second row, 1, 1, 0. 0 minus 1 minus 1, 0. So I add now 1, 1, 2, 0. Multiply by 1 and add it to the third row, 0, 0, 0, very clear. So what we have? We have K2 equal minus K3. And from here, I have K1 equal minus K2 minus 2 K3, which is K2 is minus K3, so that will be minus K3 also. So let K3 equal minus 1. K1 will be K2 will be 1. So my V1, 1, 1 minus 1. We have only one eigenvector. So it will be the defect. D will be K minus P, which is now we have multiplicity 3. We have here multiplicity 3. So I have 3, which is K minus 1. The defect is 2. So I have which case? Not this one. The defect is 1 here. I have this case. So I'm looking for A minus lambda I cubed. And then I'll find U1 satisfying these two. and then find U2, U3, and then find the solutions. Okay. I need, yeah, I need A minus lambda I square. That will be what? What is the form? What is the matrix? 0, 1, 2. No, 0 A minus lambda I, which is 1, 1, 2. 1, 1, 2. Minus 5, minus 2, minus 7. Am I right? Yeah, this one, which is 1, 0, 1. 1, 0, 1 times this. 1, 0, 1. Do the calculation. First row, my first column. You get what? 1 minus 5 plus 2, that will be minus 2. First row times second column, 1 minus 2, that is minus 1. Okay. First row times third column, 2 minus 7 plus 2, that is minus 3. Okay. Now second row by the first column, we have what? Minus 5 plus 10 minus 7, that will be minus 2. Same. Interesting. Second row by second column, we have what? Minus 5 plus 4, which is minus 1. This is minus 5, minus 10, plus 14, minus 7. Yeah, minus 10, plus 14. This is 4, minus 7. That will be minus 3. Interesting. Now the third row, 1 plus 1, that will be 2. That will be easy. Only the, yeah, you need only the first and the third, because this is 0. So I have 1. I have 2 plus 1, which is 3. Now what will be A minus lambda I cubed? That will be 1, 1, 2, minus 5, minus 2, minus 7, 101 times minus 2, minus 1, minus 3, minus 2, minus 1, minus 3, 2, 1, 3. Yeah. First row times the first column, have minus 2 plus 4, that will be 0. Minus 1 plus 2, that will be 0. Minus 3 plus 6, that will be 0. The second one will be the same, because I have to like the same, yeah, or yeah, if we do it, it will be the same. First row. I mean, the columns are the same. If you notice, the column are just multiple of a number, sometimes negative, sometimes positive. If you do it, it will be 0, 0. You do the last one, for sure, it will be 0, 0, 0. So we need to choose U1 such that A minus lambda I cubed U1 is equal to 0. Be careful. But A minus lambda I square U1 not equal to 0. Now, if we choose that U1, usually try 1, 0, 0. For sure, this will be satisfied since this matrix is 0 matrix. So any vector can work out. This one times, if multiplied by 1, 0, 0, for sure, I'm not getting the 0 matrix. Yeah, because it will be minus 2, the first. It will minus 2, minus 2, 2, which is the first column. So my choice is correct. Satisfying this and this. Okay, that's it. So, okay. Yeah, if you want A minus lambda I squared times U1, to be sure, that will be minus 2, 2, which is not the 0 vector. So this is correct choice. So now what will be U2? U2 be the matrix. You have the formula, just to remind you about the formulas. Not this case, What will be U2? A minus lambda I times U1. And what will be U3? A minus lambda I times U2. Which is the square root? Okay. U2 will be A minus lambda I, which is 112 minus 5 minus 2 minus 7, 101 times U1, which is 100. Usually try to choose U1, easy one, so that the calculation will be easier. That will be, actually, I need only the first column, 1 minus 5, 1. And U3 will be A minus lambda I, and let me write the formula, A minus lambda I times U1, and this is times U2. That would be 112 minus 5 minus 2 minus 7, 101. Do the calculation. 1 minus 5, 1. That will be what? Yeah. Do the product. 1 minus 5 plus 2. 3 minus 5, that is minus 2. Minus 5 plus 10 minus 7, that is minus 2. This is 1 plus 1, that is 2. If you notice, this one, U3, this is the most important. Yeah, just a checkpoint for you. This is U3 is a scalar multiple of this. This is a scalar multiple of V1. You notice? Yeah. So this is like an eigenvector for the system. Now the solutions. Solutions. I have x1 is U3 is minus t. What is U3? Is minus 2 minus 2 to is minus t. X2 will be what? Will be U3t plus U2 is minus t. What is U3? U3 is minus 2 minus 2, 2. Don't forget to have t here. U2 is 1 minus 5, 1 times is minus t. And this is will be equal to what? That will be 1 minus 2t. And minus 5 minus 2t. And 1 plus 2t. Yeah. Is minus t. That will be your ut. 1 minus 2t minus 5 minus 2t, 1 plus 2t. Now x3 will be u3 t square over 2 plus factorial, which will not make a difference, u2t plus u1 is minus t. Yeah, be careful here. What is u3? Is minus 2 minus 2, 2 times t square over 2. u2 is 1 minus 5, 1t, and u3 and u1, I mean, it's backward. That will be 1, 0, 0 is minus t. Sometimes they call it v3 and v2, v1. Yeah, or v1, v2, v3. The way you like it. Okay. Just a representation. That will be what? Minus t square plus t plus 1. This is the first one. Second one is minus t square minus 5t plus 0 plus 1t plus t square, I mean. 2 times t square over 2, that will be t square plus t. Don't forget e is minus t. What will be my general solution? C1x1 plus C2x2 plus C3x3. And this is what we are looking for. Now we did examples, I think, in each case. And we did also one more example. Okay. Now let me go to the old exams questions. Usually in the old exam questions, either it's the first case where I can get eigenvectors, completely eigenvectors. I have lambda repeated, but still I can get eigenvectors, so that we can solve it like what we did in 7.3. Or this if you want the general solution, you can do. Okay. Or this is the one usually came. He gave you 3 by 3 matrix with only one eigenvalue, defective D, defect is 2. He will choose V3 for you. Now, for multiple choice questions, he must choose V3 for you. Why? Because otherwise, you cannot control the answer. Because if you put another V3, you will get a different answer, which is very complicated to be written as multiple choice questions. Okay, let's do the calculations here. See what will happen. Yeah. Now he gave me the lambdas. He gave me the lambdas. So I have lambda 1 is 2, lambda 2 is 3, and lambda 3 also 3. So now we'll do the eigenvectors. So it will be for lambda 2, that will be what? 2 minus 1 minus 1, 1, 0 minus 1, 1 minus 1, 0. Is it? Yeah. Times K1, K2, K3 equal 0, 0, 0. So what we have 2K1 minus K2 minus K3 equals 0. And you have K1 minus K3 equals 0. You have K1 minus K2 equals 0. So from here, I have K1, K3. And from here, I have K1 equal K2. Or I can write it the other way. So write everything in terms of K1. Yeah, better. Write it with one variable, K1. And this is K2 equal K1. So my free variable is K1. So I will let K1 equal 1. That implies K2 equal K3 equal 1. So my V1, which I want it to be like this. This is 1, this is 1. So V1 will be 1, 1, 1. So my A is 1. Now we'll come to for lambda 2 equal 3. Let us see what will happen. I have 1 minus 1 minus 1. 1, 2 minus 3 is minus 1 minus 1. 1 minus 1 minus 1 times K1, K2, K3 equals 0, 0, 0. So I'm getting only one equation, which is K1 minus K2 minus K3 equals 0. So I have K1 is K2 plus K3. Very clear, I have two free variables. So I can get two eigenvectors. Two free variables, yeah. Let me write it. Two free variables, okay. Now, do the strict, what are the free variables? K2, K3, huh? So I let K2 equal 1 and K3 equal 0 and K3 equal 0, K2 equal 0 and K3 equal 1. So that implies K1 is 1. That implies K1 equal 1. This is what I have. I have K1 here 1 and K3 is 0. So this is V2. This implies V2 is 1, 1, 1, 0. And this implies V3 1, 0, 1. So very clear to me, this is C is 1 and B is also 1. Yeah. And B is also 1. Correct? Yeah. Actually, it comes like that, or it will be a scalar multiple so that you can figure it out. So what I need A minus 2B plus 2C. That is 1 minus 2 plus 2, which is 1. So this is my answer. Yeah. This one, you want me to find the general solution. So I need to do the full calculation, which is sometimes is not easy to figure, since I need to choose the I need to choose U1. Let me try to get the same answer. Okay. It will be a scalar multiple, you will see it. So find lambda. This is 2 by 2. I have what? 1 minus lambda minus 3, 3, 7 minus lambda. That will be lambda square minus 8 lambda plus 7 plus 9, which is lambda square minus 8 lambda plus 16, which is lambda minus 4 square equals 0. So lambda is 4, 4. Check the eigenvectors. I have what? Let me do it quickly. 1 minus 4, no, for lambda equal 4. You have what? 1 minus, that will be minus 3 minus 3, 3, 3. So very clear, I have only one eigenvectors, but I have k2 equal minus k1. I have only one eigenvector. So that implies D will be 2 minus 1, which is 1. This is multiplicity 2. Okay. Yeah. So I have this case. Yeah, this one. So I need to find square. Then I try to choose U1, and then I get U2, then I get the answer. Okay, let us do it using the same procedure like what we did before. Not sure if that. Okay, so we'll find now A minus the I square, which is what? 1 minus, what is the matrix? Yeah, minus 3 minus 3, 3, 3 times itself. That give me what? 9 minus 9, 0. 9 minus 9, 0. Minus 9 plus 9, 0, 0, 0. So I'll try to choose U1 such that A minus lambda I times U1 square is equal to 0. But A minus lambda I U1 not equal to 0. How to choose U1? I let U1 equal, as usual, 1, 0. Yeah, 1, 0 will satisfy. Yes. With the square, it will be okay. And with A minus lambda, yeah, this one 0, 0. So this is always correct. Choose any vector, it will work. Note A minus lambda I U1 is what? Yeah, very clear. It's not 0, 0. That will be the first column, which is not equal to 0, not the 0 vector. So my choice of U1 is correct. Now it will be U2. It will be A minus lambda I U1. And that will be what? Times 1, 0, which actually we did now, minus 3, 3. So what are the solutions? X1 will be U2 A40, my lambda is 4. That will be minus 3, 3, A4. Either you'll see the same or scalar multiple of it. X2 will be U2T plus U1 A40. That will be minus 3, 3 times T plus, what is my U1? 1, 0 times T. Yeah, and that is minus 3T times e to the power 4T, sorry. E to the power 4T. Minus 3T plus 1. Here I have 3T e to the power 4T. What will be my general solution? C1 x1 plus C2 x2, which is, by the way, it works with this one. However, if you choose a different U1 satisfying condition, then you will get a different answer. So this cannot be controlled. So usually the questions in the multiple choice, it will come like this. I said there is an eigenvalue of defect 2, because if there is no defect, then you can work it out like 7.2. And then he will choose V3 for you. If he did not choose V3 for you, then the calculation will be very complicated. I mean, and every choice of U3 or V3, it will give you a different answer. He called it VU, it's okay. So what I have now, this is V3, huh? Which is U1. Usually work it out as U1 in our explanation. So let me do it like U1. So I have U2, A minus lambda I, what is lambda? Minus 1 times U1. And that will be what? Yeah. That will be, I have lambda minus 1. So minus 1 minus 1, that will be 0, 0, 1. 0, 0, 1. Yeah. Minus 1 minus 1, that will be 1. 1 minus 1, 0. Times U1, which is, he chose it 1, 0, 0. That will give me what? First row. That is 0, 0. The last one is 1. This is U2. U3 will be what? A minus lambda I times U2. Now I have it. 1 minus 1, 1 times 0, 0, 1. That will be what? 1, 1, 1, 1, 1. Okay. So now what will be my answers? X1, U3, which is, you can write it V1. Yeah, the way backward and forwards. Okay. E to the power, what is my lambda? Minus T. And that give me 1, 1. Yeah, there is a mistake somewhere. Which was 1, 0, 0. So this times this 0, 0. And the last one is 1. Okay. Now I need to multiply the same matrix. This one, give me 1. This one, give me 1. This one, give me 1. Strange. Yeah, sorry, this is 0. Yeah, this is 0. Yeah, this is times 1. So this is will give me 0. Sorry. This is 0. Wrote it wrong. So this is 0. Because I noticed there is no 1, 1, 1. So there is something wrong. Okay. This is x3. A minus t. X2 will be what? U3t plus U2 A minus t. That's 1, 1, 0. T. What is U2? 0, 0, 1. All of this times ES minus t. That gives me t plus 0, t 1, e to the power minus t, which is this one. This is my x2. Okay, x3 will be u3 t square over 2. Don't forget the over 2. u2t plus u1. Yeah, be careful now. What will be the vector here? u3 is what? 1, 1, 0 t square over 2 plus u2, which is 0, 0, 1 times t. And the last one, 1, 0, 0, 1, 0, 0. Don't forget ES minus t. Yeah, times ES minus t. Yeah. So that will be what? T square over 2 plus 1. This is the first row. Second row, it will be t square over 2 0, 0. That's it. The last row, 0, t. T plus 1. T, that's it. T, which is this one. So this is my answer. As I said, usually we have the questions about this section like this, or it gave you you get a complete. My eigenvalue repeat has multiplicity, but it's a complete one, so I can find the same number of eigenvectors. Other than that, this one, yeah, you cannot control the answer. The matrix has a defective eigenvalue of this. If we choose, as I said, he choose V3 for you. Also, you need to check A minus lambda I squared times V3. This is not equal to 0. We call it U1, just to make the calculation easier. So what I have, U2 will be what? Let's write the formula for U2 and U3 here. U2 A minus lambda I U1, and that will be 1 minus, just a diagonal, 0, 2, 0, 1, 0, 2, 0 minus 1, 0, times 1, 0, 0. That give me what? 0, 1, minus 1. 0. No, sorry. 0. Be careful with the calculation. U3 A minus lambda I times U2 equality 1. Make it here. That will be 0, 2, 0, 1, 0, 2, 0 minus 1, 0 times 0, 1, 0. That give me 2. Yeah. Then I have 0. Then I have minus 1. Okay. What will be x1? X1 will be U3 e to the power t. That 2, 0 minus 1 e to the power t, which is this one. Actually, I can't figure out. These answers are wrong. Now we'll find U2. That will be U3t plus U2 x2, I mean the x2, the solution, second solution, times U2 ut. U3t plus U2 times et. That will be what? What is U3? 2, 0 minus 1 times t. U2, which is 0, 1, 0 times et. That give me what? 2t. Here is 0, that will be 1 minus t. Et, which is this one. Yeah. X3 will be U3 t square over 2 plus U2t plus U1 e to the power t. And that equal to what? What is U3? Minus 2, 0. Not 2. Yeah, be careful. 2, 0 minus 1 times t square over 2. U2, 0, 1, 0 times t. U3 or U1, which is 1, 0, 0 times e to the power t. That will be t square plus 1. This is 0 t. This is minus t square over 2. That's it. E to the power t. This is 0, 0. So I have this one. So this will be my correct answer. Yeah. That was a question when we have true false sometimes questions. If lambda is repeated eigenvalue, it is a defective? No, this is false. Why? Because if I have lambda with multiplicity k, and I can get k linear independent eigenvectors, then lambda is a complete eigenvalue. It's not defective. Not defective eigenvalue. And we saw cases like that. Find the general solution. That was when we have a written exam. It can be done like this. Yeah, if it's a written exam, I can do it this way. But if it is multiple choice, it's usually do it. Yeah, it will be very complicated to get the answer unless you have initial condition that will force you to get the answer, or they will do it. They will give you the quality U1, quality B3, quality the way you like. Notice this is the usual one, or I have initial condition, or this is written. These are the questions which I will do. Okay, so let me do this one. Okay, I have A minus lambda I. I think this is very easy. 1 minus lambda 2 minus 1, 0. 1 minus lambda 0, 0, 0, 1 minus lambda. Yeah, that's very clear. It's 1 minus lambda cubed. So lambda 1, 1, 1. So I have multiplicity 3. Okay. Now we'll try to find eigenvectors. So for lambda equal 1, what I will get? I will get 0, 2 minus 1, 0, 0, 0, 0, 0, 0, times k1, k2, k3. So I have only this equation, 2k2 minus k3 equals 0. In other words, k3 equal to k2. So what are the free variables? Notice I have two free variables, which is k1 and k2. K1 I have no restriction on it, and K2 now K3 depends on K2. So these are my free variables. So I let, as the usual procedure, I let K1 to be 1 and K2 equal 0, and K1 equal 0 and K2 equal 1. I get now here K3 is 0. Here I get K3 equal 2. So it will be V1. That will be 1, 0, 0. What will be V2? That will be 0, 1, 2. Yeah, which is these things. So I have, what is D? What's the defect? It will be K minus B. I have two eigenvectors, two linear independent eigenvectors. So the defect will be 3 minus 2, the multiplicity minus the number of linear independent eigenvectors. That will be 1. So in which case, yeah, this is the case. You have multiplicity 3 and the defect is 1. So I'll find these two easily. I get the eigenvectors. Now we'll do this, the long procedure. Now find A minus lambda I square. That will be 1, 2 minus 1, 0, 1, 0, 0, 0, 1. Okay. Times itself. No, wait a minute, wait a minute. This is 0. This is 0, this is 0. Yeah. Yeah, this is the matrix. This is A minus lambda I. Yeah, I need the times itself. 0, 2 minus 1, 0, 0, 0, 0, 0, 0. Yeah, that will be what? That will be this times this is 0. This times this, 0. This times this, 0. The rest are zeros. So it's a 0 matrix. Okay, so I need to choose U1 such that U1 is equal to 0, but A minus lambda I, U1 not equal to 0. Yeah, this is the condition. If you remember in this case. No, in this case. Yeah, this is U1. Okay. So now let me do the calculation. Yeah, this one, it gave you the zero matrix, so that will, anything can work out. You cannot control it. Okay. So now choose U1. What is A minus lambda I? Let me have A minus lambda I in front of me. 0, 2, minus 1. 0, 0, 0, 0, 0, 0. That is A minus lambda I. Now if I choose U1, as usual, 1, 0, 0, this is will be 0. So this is not good. Times 1, 0, 0. This you are getting 0, 0, 0. So this is not good. So let me choose. Yeah. I can't choose either 0, 1, 0 or 0, 0, 1. Yeah. I can't choose, for example, 0, 0, 1. Let me choose 0, 0, 1. See what will happen. Then I have A minus, this one will be satisfied, and this is the zero matrix. A minus lambda I times U1 will be what? 0, 2, minus 1, 0, 0, 0, 0, 0, 0, times 0, 0, 1. This one times this one, that will be minus 1, 0, 0. So it's not the zero matrix. So this is okay. Now what will be U2? U2 will be A minus lambda I U1. And what is U1? Sorry. What is U1? What is A minus lambda I first? That will be 0, 2. I got it here. It's minus 1. So this is, yeah, I did the calculation actually here. So that will be minus 1, 0, 0. So now it will be my third solution. It will be U2 T plus U1 e to the power. What was my T? What was my lambda? 1 e to the power T. That will be minus 1, 0, 0. T plus U1. What is U1? U1 is 0, 0, 1. All of this times 80. And that give me minus T. 80 minus T. 0. Minus T 0. And 1. 80. Which is this one? Yeah. And the other two are there. So my general solution, X will be C1 X1 plus C2 X2 plus C3 X3. Yeah. Okay. This is the question where we have, you know, initial condition. He told you that we have only one eigenvalue, lambda equal to, and defect 1. So right away, I need to choose U1. What will be A minus lambda I? That will be, what's the eigenvalue 2? So it will be 1 minus 1, 1 minus 1 times K1, K2. No need to do this. But this is A minus lambda I. As a matrix, it will be 1 minus 1, 1 minus 1. I need A minus lambda I square. That will be 0, 0. Yeah, actually, carry Hamilton theorem will tell you that will be 0, 0, which is 0, 0. So choose U1 such that A minus lambda I times square times U1 equal to 0, but A minus lambda I U1 not equal to 0. Okay. Now let me choose U1 to be 1, 1. Yeah, you 1, 0, I mean. Let U1 equal 1, 0. So times This is 0, 0, so this is always correct. For this one also it's correct. Actually, I needed to find U2, so let me do it. 1 minus 1, 1 minus 1 times 1, 0. I'm getting what? 1, 1. Okay. So not 0. So my U1 is a good choice, and I got U2. This is my U2, actually. So my first solution will be U2 times what? Times, yeah, U2 times, what is e to the power 2t? E to the power 2t. And that will be 1, 1, e to the power 2t. X2 will be U2t plus U1 e to the power t. What is U2? Is 1, 1 times t. U1, what is U1? Which was it, what? 1, 0 e to the power t. And that will be t plus 1 and t e to the power t. Okay. Now what will be my general solution? Then I will do the initial condition. General solution equals C1. What is it? C1 x1 plus C2 x2. That will be C1. 1, 1 E2t plus C2 t plus 1 t e to the power t. Yeah. Okay. Now we'll do the initial condition. I have the initial condition x at 0 equal 1 minus 1. So I have 1 and minus 1 equal, at 0, that will be C1, 1, 1 plus C2 t equals 0. That will be 1, 0. E to the power 0 will be 1. So no worries. Huh? Yeah, sorry, this is e to t. Huh? T, everything is 2. The eigenvalue is 2. Yeah, I have 2 here. Okay. So that implies C1 plus C2 equal 1 and C1 equal minus 1. Plug it here. So I have C2 will be what? 2. Huh? Yeah, minus 1 take that as 2. So it will be my solution will be minus 1, 1 e to t plus 2, 1 t plus 1 t e to t. Yeah, that will be what? Minus 1 plus 2t plus 2, and I have minus 1 plus 2t times e to the power 2t. That give me what? 2t plus 1, and this one 2t minus 1 e to the power 2t. This is exactly this one. Yeah. I think we did a good number of questions. Let me stop the recording, then I will do the rest in the next video, inshallah. Okay. I will stop the recording. Thank you.